Thank you very much for the kind introduction. I'm gonna try to do something adventurous. Tere hommikust. I'm delighted to be here in front of you in this beautiful town of Tallinn. I just follow on the messages of my director, Elodivio, who could not be here with us. And I'm going to try to illustrate a little bit what we are doing in the European Space Agency and, more importantly, what we are proposing for the future. And in order to do that, first I would like to invite you to a little trip with me. And I will explain the trip. We are on the surface of the moon. We are astronauts walking on the moon, and we are going to be seeing the projection of a video using extended reality upon the helmet of the astronaut. So I explain that because you will see some movement as the video plays along. So if we can please play the video.
We're going back to the moon. For the first time in more than half a century, humans will walk on the moon again. But this time, we'll feel closer. In the decades since we've been away, the giant leaps have happened here. The people on our planet have learned to thrive in a digital world, a connected world. The people who next walk on the moon will now be able to enjoy this same connectivity because of ESA's Moonlight Initiative. A lunar constellation of satellites and base stations providing seamless connectivity back to Earth, allowing new possibilities for discovery. To communicate. To navigate. And to explore our place in the universe more deeply than ever before. With more countries than ever set to embark on their own lunar programs, Moonlight will support a permanent lunar space station that will orbit the moon. A gateway to these further journeys, so instead of going back, we can go forward to the moon, together, and this time, to stay. Moonlight will help us safely touch down on the surface and touch base with our colleagues and loved ones once we're there, keeping us constantly connected with home as we venture further and further away from it. Pushing the boundaries of science and exploration beyond our planet, beyond the moon and Mars, and beyond our imaginations.
Right. Thank you very much. I hope you liked the video. It's not a Hollywood production, but actually is a proposal that we are making to the next event for ESA. That is the ministerial conference in around 1 month from now. And this is about providing telecommunication and navigation services on the moon surface and in orbit around the moon. And for that, we are proposing to launch a set of satellites that will be circling around the moon, and in such a way that when we are sending astronauts, when we are sending humans, when we are sending robotic missions, those can concentrate on what is important for the mission and not to have to care about the communication services. In the same way that we don't care about the device that we are using, we know it's going to work. This is about what we are proposing, so that in the future, the astronauts have to care about what they are doing, exploring or exploiting on the moon surface, and not so much about what the means are to communicate. So this is just an illustration of one of the proposals we are making to the ministerial conference. But let me make a step backwards and basically introduce, for those of you in the audience that are not familiar, in just a few words, the European Space Agency. We are an intergovernmental organization that is formed by 22 member states, and we have 4 associate member states. And we have existed since 1975, and we have launched, of course, a large number of satellite missions. We have basically a budget, a yearly budget of roughly 6.5 billion euros, which might sound a large sum, but if you divide it by the number of the population in the European states that form ESA, is basically 12 euros per European citizen. So it's not that much for what we are offering in return for that amount of money. And one thing also I would like to clarify is that we are not related with the European Union. We are working together, as my director said a few minutes ago in the video. We work together with the European Union, but we are not part of the European Union, which means that we have our member states are not necessarily members of the European Union. Right. This is just, in a nutshell, what we are proposing ESA to the ministerial program in telecommunications. And you see the numbers are still dancing. There is a negotiation ongoing between the different member states and ESA. But nonetheless, the first to your left is what I call the backbone of what we do in telecommunications. It's called ARTES, is our research and technology development program. And there we are focusing efforts on basically 3 lines that we call strategic. One is about optical communications and quantum communications, starting with quantum key distribution, but moving forward in the future into quantum communications. The second is about safety and security from space. I think I will illustrate maybe a couple of examples there. The third one is 5G and 6G. That can be an element of what I illustrated as Moonlight. The communications is based on standards, and we are strong supporters of telecommunication standards. And then we have some tools that have been used along the years and have been optimized along the years that are related with partnership projects with the private sector. We are supporting industry competitiveness through a line on technology and product development, and we are supporting the downstream development of business applications. Then to your right, on the top part, is what Elodie explained as a key important program now, because it's about the future secure communications of, in this case, the European Union. So the European Union has decided that it was strategic to set up an infrastructure in order to provide secure communication, not only among, say, the European Union and its institutions, but also among its member states. And we are associated to that effort of the European Union and proposing a program in ESA that will support that development. And of course, I mean, very much into the focus of this conference, it's all about super high security, and this is a key aspect of the program that is being defined at the moment. Third, on the bottom left, small part is Moonlight, the one that I illustrated with the video. It's about, as I said, bringing communication and navigation to the moon. And we have efforts already ongoing in order to prepare for that. And last but not least, we have a program on civil security from space that is about ensuring that we have the means in telecommunications of preventing as much as possible a crisis, but also responding to crisis. And this is a joint effort that we have between the area of Earth observation and the area of telecommunications in ESA. This is just selected, let's say, examples or illustration of the different aspects that we propose in the program. I would say of most relevance in this conference is the area of artificial intelligence, cloud, and security. And of course, I mean, these are basic technologies, enabling technologies that have ramifications into the different application fields. Be that downstream applications, the way you see a number of illustrations there, be that in the connectivity of vehicles and I mean transport in general, or be that on the moon. I mean, obviously, the aspect of security is key into the different domains. And I will come with a more concrete example later on. Now, what we are doing basically in essence is addressing a phenomenon that we are all living through, that is the phenomenon of digitalization. Digitalization of our society, digitalization of our businesses. And what this requires is connectivity at any time, anywhere, and at the speed that is required by the different services and applications. And we are strong supporters of open standards, and in particular 5G, as the means of supporting that digital transformation in order to provide a seamless connectivity. I mean, I think for those that are not familiar, the terrestrial networks have a very wide coverage. Basically, I mean, we see connectivity almost anywhere, but not everywhere. And that not everywhere makes a big difference. And this is where the satellites have a critical role in order to ensure that when they are critical businesses or critical applications, that the connectivity is there when it is required. And I will illustrate in a second with a small example, a use case. Now, just it's always good to talk a bit about the money dimension. And basically, I mean, analysis says that the impact of 5G and later on 6G into the economy is expected to be around $13 trillion US. Out of that, the expectation is that the part corresponding to space, to the satellite dimension, into that big 13 trillion economical ecosystem is 530 billion, which is a very moderate quantity when you compare with the 13 trillion. However, for our dimension as an economy, as a part of the economy, is a big jump from the current situation of satellites or the satellite input into the economy. So this is a source of big growth that is coming thanks to the support of satellites into this phenomenon I mentioned, that is the digital transformation of the economy in particular. Now, we decided a few years back to make of the role of satellites into 5G and later 6G a strategic line. And we did that basically by figuring out, by understanding that the contribution that the satellite provides into the digital economy, into the improvements of daily life, into the inspiration for future generations, comes from the nature of the satellites, which provide seamless connectivity, therefore ubiquity of services everywhere and anywhere at any time, and increases the resilience of existing terrestrial networks. And these attributes were the ones that we focused on when we decided to focus strategically on the role of space into 5G and 6G. And here, just an illustration of a few of the areas. We is an innovation agency, so we support technology development, we support standardization efforts, we support demonstrations, experimentation using test beds. We created a concept called Hub as an open innovation laboratory to open up to downstream, for instance, downstream applications to do testing into an integrated satellite terrestrial environment. These are things that we do looking into downstream business, or what people call vertical business sectors. And the obvious ones are the mobility ones, transportation, be that at sea, air, or ground. And as we are moving into more connected vehicles and autonomous vehicles, obviously the availability of connectivity is more and more important. No? So we are focusing a special effort into those domains of autonomous vessels, drones, and also, piloted aircraft that more and more are using support that increases the autonomy of the vehicle. And logistics, transportation, and so on and so forth. And as I said, I wanted to illustrate this. This is one example I always like to use because I think it's quite illustrative. This is a digital mine, or what people call the connected digital mine. So it's a remote area where there is a mining exploitation. And more and more, the idea is to use robots, to use autonomous tools for the extraction of mineral, for the transportation of that mineral, for the refinement, whatever is done on site. And of course, while doing that, there are aspects of safety, security, there are aspects of environmental protection, and there are aspects of operational efficiency that require a lot of sensors distributed there and a lot of communication to a remote area that could be a headquarters somewhere in a civilized place where decisions are being taken. So the illustration for me, the paramount illustration of the digital transformation is this kind of use case, no? Where you are taking decisions, some of them planning, some of them in real time, that are ensuring the safe operation of in this case, the mine, and the efficiency, operational efficiency of whatever else is being done there. And for that, the satellite is paramount, because I would like to insist, this is a remote area. It would be very expensive to cover this particular area with terrestrial means if it's far away and you have to connect fiber and radio and so on. Now, we have, in the last years, put a lot of effort to ensure that satellite is part of the 5G set of standards. And we have tried for many, many years. We knocked at many doors, and we were told repeatedly, satellite is a last resort, you are too small, we don't need you. 5G, we insisted, and after 2 years of effort, the community in 3GPP, that is the one that is defining the 5G set of standards, realized that maybe, what we were proposing was not too bad. And so maybe it was a good idea to include the satellite. And I'm very pleased to say that since the release 17 of the 3GPP set of standards that is defining 5G, satellite is part of that release. And we have basically 2 dimensions. One dimension that is more for broadband communications, is based on what technically people say is the new radio, for NTN standing for non-terrestrial networks. And this includes, of course, the satellites. And there are all the different protocols and waveforms and so on that are part of that standard, so that connectivity via satellite can be equivalent to the connectivity that is provided by the base stations on the terrestrial cellular network. And the second dimension is the Internet of Things that is booming. And of course, I mentioned in the example the mine, these sensors are forming what is today called the Internet of Things. And again, the satellite is included as part of that standard, defining specifically how to connect devices using the same standard and the same equipment as for cellular connectivity via satellite. Now, I mentioned earlier that one of the things that we do is open innovation laboratories. And this is an example that we have set up what we call a 5G, 6G hub in in Harwell in the UK, in our premises there, as an open laboratory that has the means of connecting terrestrially using 5G, as well as via satellite. And this is an open laboratory where we invite all kind of, say, partners, be that upstream or downstream, to come and plug their equipment, to plug their applications, and do some end-to-end testing of functionality and performance. And there we are trying to foster a relationship of actors that has not traditionally happened, that is between the mobile network operators and the satellite network operators. This has been living in separate worlds, and now with initiatives like this Open Innovation Laboratory, we are hoping that the cooperation between those actors will strengthen. And now, in the next minutes, I move into my favorite topic of the day, is 6G. So 5G is the present. And even if today we are still seeing the initial rollout of infrastructure for 5G, we are already engaging into efforts into 6G. And we are not alone. I mean, many groups around the world are already engaged and have published a vision about 6G and are defining what 6G could be like. I mean, for the moment, it's something that is abstract vision, and people talk about the metaverse or talk about extended reality everywhere and so on. What I like is this particular illustration that I explained that 6G is a network of convergences. And basically, I use three different dimensions of convergence there. The first one is what many people talk about, that is the convergence between the physical and the digital worlds. And people talk about digital twins. People talk about, I mean, how we are using data in order to increase the perception of reality, or help with data to perform routine operations, be that design, maintenance, repair, safety, health, in many different applications. So this is one of the dimensions of convergence that I like to mention. The second one is the first time that a communication standard is addressing the convergence, not only about connectivity, but also about computation. And everybody is familiar here with the cloud, the cloudification, and so on and so forth. With 6G, for the first time, people are talking about a unified network that will cater both for the connectivity between different people, things, the connectivity of everything, and at the same time, computing. And so it's, let's say, the internet with the different nodes. As we move into more and more complex applications that require lower and lower latency, there is a need of processing the data as locally as possible. And there is where this convergence of communication and computation is very critical, and we see that the realization of that will come with 6G. And the last dimension of convergence is that of the convergence of all the telecom networks. I think few people, as a minimum, I'm one, I'm not using anymore fixed telephony. I mean, everything is mobile for connectivity. The fixed network exists, but is a mere connection of optical fibers. So, I mean, this is the backbone of the communication network. The mobile terrestrial is what gives us the connectivity in many places, particularly in urban areas and suburban, but where there is no connectivity, a satellite is required. And there is where, with 6G, we have the paramount final convergence of all the telecommunication networks into one called 6G. For the realization of 6G, we need this kind of network, what I call the 3D network. And so, I mean, we have the usual terrestrial infrastructure. with users, vehicles, robots, sensors, and so on, base stations, and the clouds, the core network, and the backbone connectivity. And then to add to that, we are adding a layer that is called air, another one that is the stratosphere, and a higher one that is the space layer, with satellites in different orbits. And depending on the needs, it's better to use one type of satellite or another. And this is paramount, and this is a big change, because even if we have the users are moving in the wireless network as we know it, the base stations, the antennas are fixed. When we are moving into this type of architecture, you have everything that is flying up into space is moving with time. And this creates a complete different problematic in terms of the network topology and how you ensure connectivity between one point and another. Now, I mentioned that for us, 5G and moving into 6G is a strategic focus area. And we have a complete roadmap of activities. I'm not going to go into the details, but basically, I mean, you can see that we have the different dimensions from standardization into technology development, support to applications in the downstream, and doing development of the different elements, be that on the ground or in space, and obviously doing trials, testing, and demonstrations as a way of showing the satellite solution into the application environment. Now, moving into 6G, as I said, is early days. We are talking about vision and definition and so on, but we have identified already a number of key research topics, key areas that need to be developed and will form part of 6G. And this is about optimization using artificial intelligence of everything going from the so-called physical layer, the connectivity, up to the applications and through the network. Is about computing on board the satellites. That is something that is not traditionally there for the satellite community. And it's about new network architectures. I mentioned this 3D, everything moving and so on, poses some areas that are addressed by future research directions that we are active on. And this is, for me, the fantastic illustration of what we are doing. Because, I mean, everybody always says the satellite, you need to know everything before you are launching a satellite. And this is normally true. Satellites are expensive to build and to launch and last for a long time. So, I mean, people want to be very sure of what they are developing, and they do a lot of verification before launching into space. And instead, for 6G, we decided already to engage into the development of a launch of 6G satellite. And the first thing I get always as a reaction is, how can you launch a 6G satellite if 6G is not defined? And I say, well, we can for two reasons. One, because this is not an operational 6G satellite. This is a laboratory, a satellite laboratory that instead of being on the ground is going to be launched into space. And we know basically the key building blocks of some of the key building blocks of that laboratory. It's going to be, and there I listed a few technologies. It's about using artificial intelligence assistance in everything, including the dynamic allocation of frequencies for the communication, the dynamic allocation to resources in the satellite devoted to the different services. It's about even the connection between the satellite and the ground terminal being optimized thanks to AI. Never done. I mean, in all my professional career, this is the first time we are talking about this kind of things. It was all hard engineering optimization and by the best experts, and for the first time we are saying AI has a role in there. Obviously, every generation of the standard goes up in terms of frequency because there is a need of transmitting more data and transmitting at higher data rates. So in the case of 6G, we are moving into a domain that also, is super high in frequency. People call terahertz or sub-terahertz frequencies. We are talking about hundreds of gigahertz. Again, it's a big challenge for telecommunication networks in general, but for space in particular. And we are talking about a high-grade security, as I mentioned. This is paramount. This is a key aspect 6G, that I always want to explain a little bit. Security in the different generations of mobile networks is a kind of afterthought. First, we defined the network, how to connect the different elements of the network, and then somebody says, and we need to provide secure data transmission. So it's an add-on, it's an afterthought. For the first time in 6G, already the groups that are in the forefront of the definition of 6G are saying we need to think about security from day one in a holistic way, so end-to-end, and assuring the security not only of the devices and the transmission between the end users or applications, but also securing the network and all the different elements against possible threats, attacks, whatever it is. So we are talking for the first time about an integral concept of security into 6G networks. And there are a number of technologies to optimize things like AI performance and so on that I think is too detailed for this presentation. But basically, the second question I get is, okay, you know the building blocks, you can define a satellite, but to do what? You want to launch it just to show that there is a nice satellite flying? I said, no. What we are doing is, as I mentioned at the beginning of my presentation, for the first time, we are not knocking at the door of the terrestrial communication companies. They are saying out loud, we are not going to be able to deliver 6G without the satellites. So basically, they are saying the satellite is going to be needed. And this effort that we are putting here is to allow an early experimentation and integration with the people that will be designing and building 6G. And I'm talking about companies like Ericsson, like Nokia, like Huawei, like Qualcomm, that is making the chipsets that we have in our some of the chipsets in our smartphones, or MediaTek, or other companies, and many mobile network operators. These people are saying we need a satellite, and what we are trying to do here with this activity is to have a laboratory available in orbit early on so that we can do testing and experimentation, and with the hope of doing co-creation with those people so that we jointly define what can be and cannot be achieved using satellites in the context of 6G. And as I said, one of the key challenges that we will have is the fact that the satellites are moving. So this topology of the network is going to be a big challenge. So we rather start early doing testing so that we figure out what doesn't work so that we can fix it in time for the standard. And the last question, and I will finish my presentation with this, is why now? This is the other question I get. Why now? Basically, from one generation of telecommunication standards to the next is a period of 10 years. So now, starting in 2020, 2022, is the rollout of 5G. So the rollout of 6G is expected in the 2030s. And we know also from experience that basically these 10 years of defining a new generation is divided in two parts. The first part is open innovation, is research and development, where the different groups are defining the key aspects that will go into the chipsets, that will go into the network equipment and so on. The second 5 years is about formal standardization that basically is a continuous negotiation between the different players because they want to promote their IP and they want to block the IP of the competitors, and there is a kind of, say, negotiation so that we get into a consensus in the end, acceptable to everyone. So we decided that now is the moment because now the focus is in open R&D, and there we can have an influence. When we go into the second 5 years, that is 2027 around, expected, then everybody is focused on the negotiations, and therefore there is not so much room into experimentation and into finding new features and new adventures. And with that, even a bit ahead of time, I would like to close this part of the presentation, thanking you for your attention, and very happy to have supported this conference with this presentation. Aita.
Are there any questions from the room here to Xavier? Any questions? You can raise your hand. We will give you the microphone. I guess it's early in the morning. People are still shy. Any questions? Your chance to ask a question from Javier. No? Yes, there is one question. The microphone will be given.
So when building this quite generic satellite for 6G, I understand there's a computing capability in the air, right, for AI. And where are the really practical solutions coming from? I mean, for this we also need flight-ready computers, new CPUs, a lot of memory and storage, and the current systems maybe don't have those. So there's need to be accompanying technology to be able to deliver that. So where's the development going there?
Very good. Thank you very much for the question. It is indeed a very, very good question. So for this laboratory, we are, I would say, on the bleeding edge of technology. So the idea is to build it not according to the space standards. We are not using a space-qualified technology. We are using commercial off-the-shelf, as much as possible, cutting-edge technology, so that we can first test how it works in the space environment, and second, what can be achieved with those. And we are talking about memory, as you said, is about CPUs, about GPUs, is about any kind of, say, processing function. So for that, I mean, we are using a new space approach that is not traditional also in ESA, but we are, let's say, the disruptive innovation part of ESA. So the idea is to build a low-cost, CubeSat-based satellite that includes the best performing processors, as much memory as we can, and of course, doing as we can within the time frame that we have, protection against the space environmental effects, like radiation. But it's not to last 15 years. The idea is that we use this laboratory for 2 years, and then maybe we launch a second version of the one with what we have learned in the process. Maybe some technologies are not good. Maybe we need some others that are demonstrating that they are good. We need to emphasize those. So the second version would be a refinement of the first one. I hope I answered your question. Thank you. Thank you for it.